I want all of you to mute your mic. So I'm just launching ABAQUS CAE. I've installed the software in my system. So let us start with ABAQUS standard. So this is the ABAQUS GUI. So there are several terminologies, there are several tools and options in order to carry out a simulation project. So these are the options that we have got. In short, I'm telling you just the overview, and then we'll move on to directly the modeling part. So we need to model the part itself, then we need to assign the property, we need to complete with the assembly, followed by we need to address the step module, then the interaction, followed by loads and boundary conditions. We need to mesh the model itself. Later on, we can launch for the job. That means the solver can start for the calculations. Okay, so first of all, we'll click on this icon called as create part. We are under part module. This is how we create the part. Let the name be part 1, or if you want to rename it, you can put the name as plate. So since we are dealing with plane stress, plane strain problems, let us consider 2D planar deformable shell element. Let the approximate size be around 300. This is just the initial grid size. So this is the grid we have created. So if I click on this, we just need to include two vertices, two corner points of a plate. So as per this symbol, if I click on this, let me enter the coordinates for a corner of the plate as 0, 0 as per our assignment. And the next corner it has to be 150, 200 by logic. So it is 150, 200. If I click on this and close this, the plate will get created on its own, just like that. Very simple. Then I'll come on this. It's called as partition face sketch. I'll click on this. Now I will introduce the crack. I'm using this next to the icon of this plus. This is create lines. So let us say our crack is over here till here. So the crack is just a line is created initially, and now I'm going to create a circle at this point. If I click on this and simply drag my mouse freely, it will automatically increase and decrease the radius of the circle. This is in order to create J integral, which we are going to study after we complete CTOD in the class. But in order to measure stress intensity factor, this is an important input that needs to be given. Now I'm going to say sketch partition geometry as done. So right now we have just a geometry and a circle around it. Now what we'll do is we'll go to property, look into this icon over here. It is called create material. We'll click on this, and then we'll come to mechanical. There are general options, mechanical options in order to create elastic material, elastic plastic material, viscoelastic, composites, so on. It can also deal with thermal and electromagnetic properties. We'll go into mechanical under that first option, elasticity with elastic. So we don't do any changes here in the type. We'll choose isotropic itself. We'll put the Young's modulus as 200 into 10 raised to 3. Because its Young's modulus is 200 into 10 raised to 9 GPa. But when the coordinates are in mm, the 10 raised to power 9 becomes 10 raised to power 3. So the Poisson's ratio remains as it is as 0.3. Okay. Now I'm going to say okay again. Next, we need to assign a section for this. it is going to be solid homogeneous only. We'll say continue and let the plane stress thickness be 1. We'll say 1. Next, we'll click on this icon where we will assign a section to the plate. So we'll simply drag our mouse like this. This entire model will get selected. Now we'll click on done. If I say done, the current section with the material property that we created will get assigned to this plate. So that's the importance of this section assignment under property, the third icon. Now we'll say done. So once the color changes of this plate, it means that this plate has the properties of mild steel. Okay. Next, we'll move on to the assembly. Click on this icon to create the instances. I'll change the instances to independent to automatically get selected. I'll say OK, which means it got selected for the analysis purpose. But before that, we need to come up with the step module. We'll say step 1, initial, static, general, and we don't change any option over here. Linear perturbation is for buckling problems. So we'll choose general with static general only. Now we'll say continue. We don't do any changes over here. Simply say OK. Fine. Now in the next step, what we'll do is we'll move on to the interaction. In interaction, remember, this is the module of interaction. We'll come to special. Under special, we come across this crack. If we click on this, if we simply hover our mouse on this crack, we get several options. The first option is assign seam. Seam means crack only. If I click on this, and if I click on the geometry or the line that we have created, it will get highlighted with the red color. For the other part, I need to press the shift button, and then again we will press this. Now a crack is selected. Okay. So after selecting it, we'll put on, or you can press done. So now a crack is selected. Not only that, now we'll come back to special again. We'll come to the crack and then we'll say create. We need to select contour integral. Click on continue. Now we need to select the crack front itself, the end of the crack point, which happens to be this. I'll say done. Next, we'll move on to Q vectors. And we need to select any 2 coordinates and it will automatically calculate the perpendicular normal vectors. So under the singularity, we'll change the setting from mid-side nodes for, from 0.5 to 0.25 in order to get accurate results. Now we'll say OK for this and our crack is ready. So once the crack is ready, it's time to apply the boundary conditions. First, we'll try to put a load of 200 MPa as per the assignment. So we'll click on, load module. First, we'll come to load module and we'll click on this icon, create load. Okay. Under this option of mechanical, we'll come to pressure and we'll say continue. So the surface at which the loads must be applied is the top one. Simply click on that. It will get highlighted with red color. Say done and put the magnitude as -200 and say OK. See, 200 MPa has been applied now. Now, in order to create a fixed support at the bottom, I'll come and click on this create boundary condition icon. For mechanical with symmetry, anti-symmetry, and caster, I'll say continue. I'll select the bottom surface, which gets highlighted again. I'll say done. So I'm putting a clamp support. So this whole model is now clamped. You can also do vice versa. There is nothing wrong in it. Now our model is ready, and the next step is actually to mesh the entire model. So for that, we'll come to this mesh module. We'll create on this icon. We'll click on this icon and we'll say yes. Actually, a very coarse mesh is generated. Let's see how it goes. We'll come to job. After this, we'll straightaway come to job module. We'll click on this icon over here called as create job. We'll give some name for this. Let's say plate with center crack, and today's date is 6/2. I'll say continue and say okay. I will click on the other icon and I'll say submit. Okay, the software is asking, in order to generate the outputs, we need to go back to history outputs. So we'll go back to the step module. So there is this field output icon, and below this, there is history output icon. We'll click on create history output. We'll say continue. And instead of whole model under the domain, we'll say crack. And for crack, let us say there are 3 to 4 number of contours. That means 4 divisions across this circle on the circumference. And let's say the required values are stress intensity factors. So there is option for stress intensity factor here, contour integral, J integral. So first we'll try to, get the output for stress intensity factor with the crack initiation criteria as maximum tangential stress. I'll say okay now. We'll go back to job module and now we'll say submit. It may take some 20 seconds to complete the simulation, not more than that. Just a small error came. We'll go back to mesh. It's definitely the mesh itself. We'll change this to just 2 and we'll say okay. It's better we click on this called as assign mesh controls and select only the quad elements. We'll say okay. And now we'll click on this and say yes. We'll get very fine mesh. Very fine mesh. We'll go back to job module. Again, we'll submit. It is running. It completed also. See, it completed also. Now we'll go to results. Click on this results. We'll come to visualization. And click on this plot contours, this colored icon. See, the crack has opened. The crack is actually open. This is our crack. Just observe. This is our crack. It opens and also get stretched. Okay. So right now it is showing this just the von Mises stresses. This is showing von Mises stresses. These are von Mises. 55.9. 5.5 into 10 raised to 2. 559 MPa is the von Mises stress. Now, in order to find out the stress intensity factor, we'll click on job module again. We'll go to monitor. So under this monitor, we'll stretch this little bit. We'll come to data file and we'll come at the last.